We're kind of used to thinking about AI doing amazing things, right?
Yep.
But usually as these separate tools.
Yeah, like a really smart calculator here, writing assistant there.
Exactly. But what if those tools could actually, come together, collaborate, maybe even evolve inside their own persistent environments?
That's the idea. That's where we get into what are being called autonomous worlds. It's a pretty big leap.
It feels like the next stage, maybe. So today, we're doing a deep dive into this concept of autonomous worlds.
Mm-hmm. And we're basing this on a really interesting document that lays out the potential here.
Right. And for you listening, if you like getting up to speed quickly on these big new ideas without drowning in jargon, well, that's what we're aiming for today. We'll break it down.
Absolutely. And the potential applications they talk about are, well, they're really broad. Research, governance simulation, completely new kinds of gaming, community building.
It definitely sparks your curiosity. Okay, so maybe let's start with how we even got here. The document traces a kind of evolution, doesn't it?
It does. It starts way back with rule-based agents. Think really basic chatbots.
Like if user says X, respond Y.
Yeah.
Very rigid.
Totally. Pre-programmed static responses, no real flexibility.
Then we got the AI agents who we're more familiar with now, the ones powered by LLMs,
Yeah.
large language models.
Yeah, and these are much more dynamic. They understand context. They have memory of past interactions.
That's a key step, the memory and context.
Huge step. It lets them actually learn and adapt.
Okay, and after that?
Multi-agent systems. So now you've got, like, teams of AI agents, often specialized ones.
Working together on something complex.
Exactly. Coordinating, maybe dividing up tasks, like a digital project team.
Okay, so that leads us towards autonomous worlds. How do they build on that?
Well, autonomous worlds take that idea of collaboration and expand it massively. It's not just about one task anymore. It's about creating entire simulated environments, persistent places where these agents live, interact constantly, adapt to changes in their world, and potentially even evolve their behaviors over the long term.
Wow, okay. And the document even looks further ahead, right, to something called symbiotic AI human ecosystems.
Yeah, that's the sort of ultimate vision described, moving beyond just using AI as tools to a future where humans and AI are deeply intertwined.
Co-creating, innovating
Yeah.
together.
Maybe even co-governing spaces, both digital and perhaps even physical. It's a pretty profound shift they're outlining.
It really is. So the fundamental idea here with autonomous worlds is that they're not just complex software anymore.
Right. They're framed as dynamic, evolving systems, things that could actually push the boundaries of AI itself.
So what makes an autonomous world an autonomous world? What are the core characteristics?
Okay, so the document highlights a few key things. First, they operate independently within their own defined rules, their ecosystem.
Self-contained in a way.
Sort of, yeah. Second, they're built for dynamic collaboration agents working with other agents and potentially humans too.
Okay.
And third, and this is crucial, they are constantly adapting and learning. It's not static, it's based on everything that happens within them.
You mentioned defined boundaries. I saw a term in the document, diegetic boundaries. That sounds specific. What does that mean here?
Yeah, that's a great term, actually. Think of diegetic boundaries as the fundamental laws of physics for that specific autonomous world.
Okay, the internal rules.
Exactly. The non-negotiable rules that govern everything inside it. They define what's possible, what's not, and create a consistent, trustworthy reality for the agents living there. The document uses Bitcoin as an analogy, which I thought was quite clever.
How so?
Well, Bitcoin's cryptographic protocols, how transactions are verified, how new coins are made, those are its diegetic boundaries. They ensure the whole system works predictably and maintains integrity.
Ah, I see. So autonomous worlds need their own set of unbreakable foundational rules to function reliably.
Precisely. That's what provides the coherence and trust.
Okay, so to actually build these worlds, you'd need some kind of, I don't know, engine or framework.
Exactly. And that's where the document introduces the Autonomous Worlds Engine, or AWE.
AWE.
Yeah. It's described as this modular toolkit, not one giant piece of software, but a set of interconnected components designed specifically for creating these worlds, simulating them, and letting them evolve.
Modular sounds flexible. Let's maybe walk through some of those key modules. First up is the world orchestration module. What's its job?
Think of the world orchestration module as the overall director or governor of the world.
Okay.
It sets up the world's initial state. It manages all the agents living in it. There's an agent registry for that, keeping track of them.
Right.
It also records everything that happens, like a history book. That's the event registry. And critically, it keeps everyone synchronized, the state recorder, and moves the simulation forward in time, step by step, using the step generator.
So it's the bedrock, making sure the world runs consistently.
Exactly. It maintains the stage for everything else.
Got it. Then there's an agent orchestration module, managing the inhabitants, I guess?
Precisely. This focuses purely on the AI agents themselves, creating them, governing their actions.
How does it decide what an agent does?
That's the activity generator. It figures out the agent's next move based on its goals, its memories, which are stored in the agent memory, and whatever events are happening around it.
An agent memory is like its personal history and learning.
Exactly. Its experiences, its learned behaviors. There's also an asset manager if the agent needs to handle, say, on-chain financial instruments.
Ah, okay. Digital assets.
Yeah. And a plugin manager, which is important. It lets agents connect to the outside world, like using third-party APIs or web services.
Interesting. Okay, then an event orchestration module. What does that handle?
This is all about the narrative drivers, the things that happen in the world that cause agents to react.
So, like plot points.
Kind of, yeah. The event trigger initiates these events. Maybe it's a scheduled thing. Maybe it's triggered by agent actions. The event memory keeps a record of past events for context. And the event monitor watches how agents respond to events, which helps calibrate future agent behavior or maybe even trigger follow-up events. It's how the world stays dynamic and responsive.
It feels like a complex dance between all these parts.
It really is. And that complexity grows when you have lots of agents. Which brings us to the multi-agent simulation module.
Okay, handling scale.
Exactly. If you want rich emergent behavior, you need potentially thousands or millions of agents interacting efficiently. This module is about making that feasible.
How does it do that?
Well, it optimizes how the underlying AI models, the LLMs, are used. That's the execution scheduler trying to be smart about API calls. It maps out dependencies between agents and tasks with a dependency graph.
So it knows who needs what from whom.
Right. It uses enhanced parallelism to spread the computing load. Global synchronization keeps everyone's view of the world's state consistent. And an LM adapter lets it work with different AI model providers, which is practical.
So it's the traffic controller for a massive number of agents.
That's a good way to put it.
Yep.
Focused on low latency, large-scale coordination.
Okay. And you mentioned on-chain assets earlier. There's a specific module for that too, the on-chain asset module.
Yep.
If your autonomous world has its own economy built on blockchain technology, this module handles that.
What does it include?
Things like a wallet manager for securing agent identities on the blockchain, blockchain integration to talk to different chains, a smart contract manager for the rules of the economy, like tokens or digital property, and even a liquidity manager to help make sure those digital assets can actually be traded easily within the world's economy.
Right, so the markets function. Okay, one more. The proof of autonomy module. That sounds pretty important.
Crucial, I'd say. This is about trust and verification. How do you guarantee that the agents are truly acting autonomously based on their programming and experience, and that the world's history hasn't been tampered with?
Yeah, how do you do that?
It uses techniques like decentralized storage, think IPFS, or similar to store the agent and world data securely and tamper-resistantly.
Yeah. A data optimizer to compress data efficiently for storage. On-chain indexing to anchor key data, like agent memories, onto a blockchain, making it verifiable and searchable. And an integrity validator to use cryptographic methods to prove data provenance and immutability.
So it's providing cryptographic proof that the world is running as intended and the history is real.
That's the goal, building trust into the system's foundation.
Okay, wow. That's a lot of modules. So bringing it all together, how does a typical interaction flow look inside this AWE framework? How does a world actually live?
The document describes it as an iterative cycle. It starts logically with world initialization.
Setting the stage. Basic rules, parameters.
Exactly. Then comes agent and event creation.
Yeah.
Designing the initial agents, their goals, maybe their starting knowledge, and curating the initial events or conditions.
Getting the actors and the opening scene ready.
Kinda, yeah. Then things kick off with event-driven agent activation. An event happens, agents perceive it, and they react based on their internal logic, their memories, their goals.
When they interact with each other.
Right. That leads to agent collaboration and adaptation. Agents talk, trade, compete, collaborate, whatever the world allows. And the system, especially the event monitor, tracks these interactions and their outcomes.
And that feeds back into the system.
Yes, that's the key. Iterative refinement. The outcomes influence future agent decisions, maybe trigger new events, potentially even lead to updates in the agent's underlying models or the world's rules over time.
So it's constantly learning and evolving. The whole world isn't static.
Exactly. It's designed to be a dynamic, continuously evolving system, not just a one-off simulation run. That integration of components is what drives it.
This is all really cool conceptually, but let's get practical. Where might we actually use these autonomous worlds? What are some applications that might give you that aha moment?
Right, the so what question. The applications are potentially huge and diverse. One big area is research and simulation.
Like testing theories.
Yeah, testing complex social or economic models. Imagine trying out different forms of universal basic income in a simulated society.
Without real-world consequences first.
Exactly. Or simulating different governance structures for online communities. Or even exploring how AI and humans can best collaborate on scientific discovery within a simulated lab.
A safe sandbox for complex experiments.
Okay.
Then there's the idea of personalized worlds, creating bespoke environments for, say, gaming.
How would that be different from current games?
Imagine game worlds populated by truly autonomous AI characters who have their own goals, relationships, memories, creating genuinely emergent storylines based on your interactions with them, not just pre-scripted paths.
That sounds incredibly immersive.
It could be. Or personalized worlds for education, or for specific online communities driven by AI agents facilitating interactions, shared, evolving digital spaces.
Okay, what else?
Well, they mentioned decentralized autonomous organizations, DAOs. AI agents could potentially make DAOs much more efficient, automating tasks, analyzing proposals, maybe even participating in governance.
Interesting. Automating parts of organizational management. And for AI researchers themselves, creating custom worlds provides a controlled environment to just study agent interactions. How do different AI architectures collaborate or compete? What unexpected behaviors emerge? And they can easily share these worlds and results.
It really does sound like, as you said, a sandbox.
Yeah.
A place to explore what AI can become, bridging the gap to potentially much more advanced systems.
Yeah, I think that's a good way to frame it. And one application area that seems particularly powerful is using these worlds to simulate and tackle real-world problems.
Okay, let's dig into that a bit more. Listeners always find the practical problem-solving aspects really interesting.
Definitely. So when you're simulating real-world challenges, there are a few key ingredients. You need sophisticated agent modeling.
Representing different people or groups accurately.
Right. Diverse goals, behaviors, resources. Then you need detailed environmental design to mimic the complexities of the real system. Maybe it's an economy, an ecosystem, a city. Interaction protocols define how agents can communicate and collaborate. And crucially, simulation rules set the ethical guidelines, resource constraints, the physics of that world.
Got it. The document used poverty alleviation as an example, right? How would that work?
Yeah, it's a compelling case study. You could populate an autonomous world with agents representing a population facing poverty.
Yep.
Then you could introduce other AI agents designed to act as, say, economic planners or community organizers, maybe even policymakers within that simulation.
And their goal?
Their goal would be to experiment with different strategies to reduce poverty within the simulation. They could test various models of UBI, perhaps.
See how the agent population reacts, what the economic impact is.
Exactly. Or they could simulate decentralized financial systems, maybe based on blockchain, to see if they offer more equitable access to resources. You could explore tokenized economies for fairer distribution.
So the AI agents are actively trying different policies inside the simulation.
Precisely. They'd be designing, testing, and refining strategies for wealth redistribution or opportunity creation, observing the outcomes in a complex, dynamic environment, but without the real-world risks of initial implementation.
That is a powerful concept, using these worlds to explore solutions to really tough global issues.
It offers a new way to model and experiment with potential solutions, leveraging the complexity these worlds can handle.
Well, this has been a fascinating deep dive. If we boil it down, the main takeaway seems to be that autonomous worlds aren't just an incremental step. They represent a pretty significant shift.
I think so. Moving towards these persistent, collaborative, evolving AI ecosystems, the potential feels vast.
And for you listening, getting a handle on this concept really gives you, I think, a valuable lens on where AI might be going next.
It touches on everything from how we might conduct research to how we could build communities or even tackle global challenges.
So it might be a final thought to leave you with. Thinking about all this potential, what complex real-world problems, maybe ones we haven't even mentioned, do you think could be better understood? Or maybe even find new solutions for by creating and observing these kinds of autonomous worlds?
Yeah, what could we simulate and learn from? It's definitely something worth mulling over.